So your first lesson here is to multiply together monomials that have a whole bunch of variables and exponents. And this is how it's done. First, you look at the numbers up front, and we're going to multiply those pretty much normally. The -4 and -6 are going to multiply themselves together, and they give positive 24. But then the variables work a little bit differently. You got to notice first up that the x's in the two monomials have powers of 2 and 3. There's this thing called the product rule, which says that when you multiply the same base together, that is x, you multiply the same variable, or even same number, you can add their exponents together, meaning 2 plus 3 makes the new exponent 5. You want to do this for every single variable or every single base that has an exponent on it. It turns out actually this y right here does as well. It doesn't appear to have an exponent, but it's assumed that the exponent is 1. When we do the y to the 4th times y to the 1st gives y to the 5th, because 4 plus 1 is 5. And then because the z squared doesn't have anything to multiply with, it just kind of stays the same. And so the result is 24, x to the 5th power, y to the 5th power, and z squared. What you should do next is pause the video and explore the second problem, the one that has 2abc times a squared b cubed d squared. Try that on your own. Pause the video. So hopefully you've had a chance to try this one on your own. It's going to be done really the exact same way as before. Because we have 1 powers over the ABC of the first monomial, that'll guide us as to how we add the exponents together with the second monomial. The 2 up front has nothing to multiply with, so it'll stay the same. A to the 1st power times a squared. That gives a to the 3rd power, since 1 plus 2 makes 3. That's the new exponent over a. And likewise, the b's will multiply together. It'll give you b to the 4th power. 1 plus 3 is the new exponent, 4. However, c to the 1st power has nothing to combine with. When we're writing the answer, we're not going to put that 1 power. It's not really proper to do that. It's important to understand it, but not to write it. And d squared, again, had nothing to multiply with. So your answer is 2a cubed b to the 4th c d squared. You're noticing already these answers can have a lot of variables to them, and they might seem messier, but what we're doing is actually called simplification because it's written in a way that's a lot simpler with less writing than the 2 things that were multiplied to begin with. And just a heads up, by the way, there is an additional concept going on here. The reason for this property is that we can take any of these problems and do what's called expansion. I'm going to write this out really fast. We already have 2abc written down. But whenever there's an exponent that isn't a 1, we can actually break it into what's called its expanded form. A squared becomes a times a. B to the 3rd power becomes b times b times b. D squared becomes d times d. All you have to do after expanding like this is simply add up the different variables. We have 1, 2, 3 factors of a. That's why we see the a to the 3rd power below. And 4 factors of b. 1, 2, 3, 4 factors make b to the 4th power below. 1 power of c, 2 powers of d, and just a lonely 2 up front. You wouldn't want to actually expand every single problem. That would take a really, really long time to do for a lot of these. But just keep in mind, that's where these properties come from, and that's an alternative way to do the question if you really have the patience to. Moving on, we're going to try an application of this that's a little bit more geometric, finding a perimeter and area of this triangle. Keep in mind, perimeter is adding together all of the 3 sides, and area has a formula for it. The area of a triangle is equal to 1/2 base times height. With that reminder, again, pause the video and see if you're able to find both the perimeter and the area of this triangle. Now that you've had a moment here to try that out, the perimeter actually has almost nothing to do with product rule. It actually has literally nothing to do with product rule. The perimeter is actually just, let me go back to dark blue. The perimeter is actually just all the things added together. 4a to the second power b plus 3ab plus 10a squared b. There's no multiplying going on. This is all adding. So you can't use this so-called product rule. Instead, we're just going to be combining like terms. And we would notice that a squared b is a like term with the other a squared b term. You have 4a squared b and 10a squared b. These will combine. But then 3ab itself is not a like term with those because it lacks the a squared. All you do for perimeter is simply combine the like terms 4 and 10, make 14, a squared b. And you leave plus 3ab as it was. It has nothing to combine with. And that's your perimeter answer. That's all you can do. When it comes to area, this is where you use product rule. If area is equal to half base times height, let's plug those things in. Half times the base, which is 3ab, times the height, 4a squared b. I'll leave that 1/2 alone for a second. Multiplying together the two parentheses, 3ab and 4a squared b, we get 12 from 3 times 4. A to the third power, because of a times a squared. Remember that there's an invisible 1 exponent if it's not shown to you. B times b is b squared. Then you ask yourself, what's 1/2 times this all? Number times number, 1/2 times 12 is 6. And you get 6a to the third power b squared. The other application we can do of this stuff is scientific notation. With scientific notation, this works because you have 10 to the fourth power and 10 squared in this particular problem. But because 10 is the same base, you're able to actually use the product rule to help you out in multiplying these two scientific notation numbers together. And then at the end, we'll have to express our answer in scientific notation as well. Again, you can pause the video and try this. The way this one's going to work out is that you're going to separately multiply your front two numbers together. We're going to say 3.4 times 7.9. We have the 10 to the fourth and 10 squared also to worry about. The product rule says we add 4 plus 2 for the new exponent over 10. Multiplying them together, we have 3.4 times 7.9 times 10 to the sixth power. Break out a calculator, figure out 3.4. Times 7.9, we get 26.86. But we need to express our answer in scientific notation. You'll remember that scientific notation means we have to actually leave just one number in front of the decimal place. We need to convert this into 2.686, and because we've moved our decimal just one place over, we will increase the power on 10. You get 2.686 times 10 to the 7th.